Have you been studying organic chemistry? Or maybe you've been practicing alkyl halides using the Cornell method after our last video, and now you want a past paper style question to test yourself. Here you go. Equal amounts of 4 bromoalkanes were added to separate test tubes containing 2 cubic centimeters of silver nitrate solution. The mixtures were heated in a water bath. Which bromoalkane would be the first to form a precipitate? A. 1-bromobutane. B. 2-bromobutane. C. 1-bromo-2-methylpropane. D. 2-bromo-2-methylpropane. All right, let's solve this with the no pen, no paper method. Remember, time is gold. For multiple choice questions, you need a solid theory and a practiced approach. What precipitates with silver nitrate? Silver bromide. Remember the color. All silver halides are pale whitish. As you go down the halogen group, the colors deepen. Chloride is nearly white. Bromide is pale yellowish cream. Iodide darker. That's a little bit of inorganic for you, but the important thing is silver plus will precipitate only when bromide ions are free in solution. So, how does bromide become free from an alkyl bromide in the aqueous medium? Through nucleophilic substitution. The speed depends on carbocation stability. The more stable the carbocation, the faster the reaction. Now, note the line in the question. The mixtures were heated in a water bath. That matters. Heat favor kinetics. Remember, in nucleophilic substitution reactions of alkyl halides, we have two pathways, SN1 and SN2. SN1 happens with tertiary alkyl halides, where the carbocation forms first, and that step is the rate-determining one. After that, the nucleophile attacks. On the other hand, primary and secondary halides usually go by the SN2 pathway. But here's the trick. The heat supply in this question speeds things up overall, and under these heated conditions, the deciding factor is carbocation stability, not the SN2 rate. So if you're worrying, maybe the SN2 reactions of the first three choices are faster. The answer is no here. Under the heated conditions, the deciding factor is carbocation stability, and make the SN1 pathway dominant when a stable carbocation can form. So check the options by carbocation stability. 1-bromobutane, primary, forms a very unstable carbocation. Slow kinetics. 2-bromobutane, secondary, more stable than primary but not the best. 1-bromo-2-methylpropane, still primary, not fast. 2-bromo-2-methylpropane, tertiary, gives the most stable carbocation and undergoes SN1 fastest under these conditions. Therefore, the first precipitate forms from 2-bromo-2-methylpropane. In pen and paper practice, write everything out step by step. That's perfect for studying. But in the exam with the no pen, no paper technique, mentally run through the logic. Only draw the structures. Our goal is to make you draw only the final answer. If you can skip sketching altogether, you're exam ready. Share this video with your study buddy. We only get when we share. Yours, Atom Academy.